Front, rear max minus 1, front is equal to rear plus 1, print fq overflow return in if front is equal to 1 minus 1, front is equal to 0, rear is equal to 0, else if rear max minus 1, rear 0, else rear is equal to rear plus 1, q arr array rear edit item operation deletion. If front, if print q underflow return, else print f element deleted from the queue is percentage dq from array. If front array front 1 minus 1 rear and else if front max minus 1 front 0, else if front plus 1 dq plus double indet q in the dq we can add or delete the element from the both side in the front end and the other front or the rear, and it is of the two types IP restricted OP. In the input restricted DQ element can be added in at only one indent, but we can delete an element from the both side in the output restricted. In the output restricted DQ element can be added from the both side, but the deletion is allowed at only one in operation in the DQ. We assume we maintain the two pointer applied which indicate the pointer DQ here, the left pointer at the position 2 and right pointer at the position 4. For IP restricted 8 into the queue from the right 5, 10, 15, 8 left to right 5, delete the element from the left in the queue 10, 15, 8 left 3 right is equal to 5, at the element 20 in the queue 10, 15, 8, 20 left 3 right 6, at the element in the queue left 10, 15, 8, 20, 16 left 3 right 7, delete the element from the right queue 10, 15, 8, 20 left 3 right 6, left 3 at the element 12 in the queue and 10, 15, 8, 20, 30 right 3 at the element in the queue left 3 right 3 with 12, 35, 10, 15 8, 20, 30 at the element in the queue 12, 35, 6, 10, 15, 8, 20, 30 left to right 3 at the element 35 in the queue. No, it overflow because the right pointer will become equal to the left pointer and never adding an element right addition if the left is equal to right max left right plus 1 print q overflow return left plus left right 0 else if right max minus 1 max minus 1 right 0 else right plus 1 dq array right edit item left addition left addition right max minus 1 left right print q overflow. Print overflow right addition print overflow left right addition left right max yield shift left minus 1 dq left right edit item delete left if left minus 1 print q flow return print f element deleted from the queue percentage q dq point delete item if the left element make empty left minus 1 right minus 1 else if left max 1 move from 0 left else left plus 1 increase 0 delete right if the left is equal to minus 1 print q under flow return print element deleted from the queue its percentage dqarr left right left minus 1 right minus 1 else if right right max minus 1 else if right minus 1 chapter 4 the linear order list. A linear order a set of consisting a number or element to which operation into the queue perform the linear list and order list considering of the number element of which operation perform in the list transferring an array list starting an element in the list, insert an element in the list, declaration of the element in the list, array implementation, take an array 10 which has a 5 element. 5 element, take an array size of 10 with the 5 element 10, 20, 30, 40, 50. Transferring an array list. Here each element can be found through the init and array increment by 1 which index 0. Then the array determines first element in the array index plus 1 array index 20, in which we can transfer each element of an array by incrementing the index by which index is not greater than of the 10 elements searching in the array list. Mm, the for searching an element, we can first transfer the array list. While transferring, we compare each element of an array with a given element int and int 0 in plus plus int arr return I plus 1 insert of the element in the linked list to insert in the insert in between insert at int 10 20 30 40 50. So set the array index to the total number of the element and insert the element index. Total number of element array index value of inserted element insertion in between 10 20 30 40 50. Shift the right one position of all array element from the last array element to the array element before which we want to insert the element in the item int and max printf list flow return if position n plus 1 print enter the position less than 0 or equal to percentage d n plus 1 return if position n plus 1 inserted in the array on insert return temperature n minus 1 while temperature position array temperature array position intern n plus 1 deletion of an element in the list, deletion of a last element, deletion in between, deletion of the last element 10, 20, 30, 40, 50 transfers the array last in the element item and the array of the delete that element and decrease the total number of element by one deletion in between first transfer the array list and compare the array element with the element which is to be deleted and then shifted one position from the next element to the last element array and decrease the total number of the element by one in position temporary item minus one. If n minus 0 present or the not element print a list under flow return if in turn deletion at the end n minus 1 return temperature position while temperature n minus 1 array temperature plus 1 temperature plus plus n is equal to n minus 1. Advantage of the list easy to compare the address of a array through which index 4 can be accessed array element through the index. Disadvantage use of continuous list which is time consuming. As an array size declared we can take element more than array size. If the element are less than the size of an array then there is the wastage of the memory. Too many shift operation on each insertion and the deletion. To overcome the problem we use the linked list deal index to the postfix conversion parenthesis. The expression is starting from the left to the right. During the parenthesis, the expression the operand associated with the operator having in this once the expression is converted to the postfix from the remove the parenthesis operation a b plus c f d minus 1 a into b c minus f a into b y minus f y x y f a b w f a b c d f w d c d let x into a b dynamic memory allocation in the array. It is necessary to declare the size of the array. This creates the two possible problem. If the record R story is less than the size of the array, then there is the wastage of the memory. If we want to store more element than the size of the array, we cannot store. To overcome this problem, we use the dynamic memory allocation. The function used for the dynamic memory allocation, function used for the dynamic memory allocation and the deallocation are the malloc, calloc, free, reloc, malloc. The function used to allocate the memory. The malloc function reserves the memory space, specified size, and gives a starting address to the pointer variable. Syntax PTR data types malloc is specified type of pointer or size required to reserve in the memory. Example PTR int malloc 10 structure, student int roll number char name, float percentage structure student PTR structure PTR structure for student malloc size of the struct student only. Calloc function is used to allocate the multiple blocks of the memory. These are the two arguments: syntax PTR data types calloc memory block size. Example PTR int calloc 5, 2 struct nodes are name int as a floor salary into record 100. PTR struct record calloc tool record size free. This function is used to deallocate the previously allocating the memory using the malloc or the calloc function. Syntax reloc. This function is used to resize the size of the memory block which is already allocated. It is used in the two conditions: if the allocated memory block is insufficient for the current application, the allotted memory is much more than what is required by the current application. To allocate the memory, we use the ptr char malloc. To relocate the memory, ptr char reloc ptrb. Chapter 5 or linked list is the collection of the element called the node, and each node has they have the two parts. The first part contains the information field and the second part contains the address of the next node. The address part is the last node of the linked list will have value address part of the node which contains the address of the next node in front of the node. In the linked list, the one member is a pointer that points structure itself. Struct node in data struct node link. Here is the member of the structural struct node link to the point and the structure itself. Implementation transferring a linked list in a linked list. Start is a pointer which points to be the first element of the list. For processing next element, we assign the address of the next element to the pointer ptr as ptr link each element linked list can travel through the assignment until PTR null address. So the linked list can be transferred as which PTR null PTR link. Searching to the linked list for searching an element in the transfer linked list with the transferring compare the information part. Each element will give an element. It can be written as while ptr null if ptr info data info item percentage found at the position percentage data post ptr link insertion into the linked list insertion at the beginning insertion in the between temp. Here is the temp is to pointer the point the node that is inserted to be temp info data start point to be element linked list. For the insertion at the beginning, we assign the value of start to the linked part of the inserted node as tempo info start, and start can be assigned as the start temporary insertion between stack point to null. First we transfer the linked list for obtained in the node which after we want to insert the element we obtain the pointer 9 which point the element after which we insert a new node. For inserting the element after the node, we assigning the part of the node and the address insert temperature info data temperature link data q deletion of the link deletion in between if the element if the element is the order than the q1 part element of the linked list, then we can give the link part of the deleted node. If the element is order than the first element, then the linked list we have to give the link part and deleted node as a link part. Stack implementation using the linked list. Stack implementation using the listing top temp for pushing element on the stack. We follow the insertion operation. Insert an operation, push operation for pushing, then element temporary queuing, push item, queuing item. Become the first node in the linked list and the linked list for the we delete the first element in the linked list is the top step in PT temp top print pop item percentage D temp info top link free temp queue implementation using the linked list front list null rear temp for adding the element in the queue we add the element at the end of the list. Here we front will put the pointer first node of the linked list. Here we point to the last node in the linked list. You can be written as temp info add item temp info null if front null front temporary rear link temp rear temp deletion operation for adding the element in of a queue. We delete first node of the linked list front temp null rear temporary the front print app queue underflow else temp front print app deleted element is percentage d temporary info front link free temp double link list dli in the single link list we can transfer only one direction because each node has a address of the next node only. Suppose we are in the middle of the list and we want to operation just previous the node, then we have to go into the previous node and we will get the transverse from the starting node and which time is consuming to the overcome the problem. We use the double linked list DLI start null information part of the node content address next node content the address of the previous node and null each node has content the information access of the address of the information of the previous node. The data structure for the DLL is struct node previous into node struct node next. Here the struct node previous is a pointer to the structure which will contain the address of the previous node and the struct node next node will contain the address of the next node in the list. Thus we can travel in the both direction operation transferring the double linked list. Start the point first element and the list we assign the value of the start ptr, so the ptr point first main node of the list. For processing the next element we assign the address of the next node, insert and starting pt in all. For insert and at the beginning, we assign the value of the start to the next part of the inserted node and then address of the next inserted node to the previous part of the start. Cal temperature next start previous temperature. Now the inserted node point to the next node with the beginning of the DLL and the previous part of the node will point to the new insert node. Now the insert node is the first node DLL, so the start will assign as start temporary. Now the start will point to the inserted node with first node DLL assign the null to the previous part. Inserted node may be previous temporary previous null. The whole process can be assigned as temporary. Next start previous temp previous insertion between start temporary a first we transfer the DLL for obtaining the node previous at the beginning time, but start the point deletion between if the element has the order than the first element in the linked list we can assign the part next in the node past of the previous node and the address of the previous node temporary queue deletion of the last node. If the node is to be deleted, the last node will be free and the last next node part and the second last will be the null. Can be written as a temp impure queue free temp next queue null priority queue. In the priority queue every queue of the some priority and based on that priority it will be processed so that the element more priority will be processed before the element which has less priority. If the element have the same priority, then in this case follow the FIFO policy struct pq int priority int info struct pq link implementation temporary info add item temporary priority item priority front step int info temporary link while queue deletion. Delete operation will be the deletion of the first element because it has the main priority and the other element of the queue. First element null pf queue underflow else temp front temp deleted item percentage d temporary free Chapter 6 recursion is defined as anything in terms itself. Recursion is used to solve the problem involving the iteration in the reverse order. Recursive function call itself repeatedly. Recursive program will not continue indefinitely. The recursive procedure main function find the factorial of any number. Main int number fact int number in scanf fact number print factorial d fact in the return result output process number 4 result 24 after every call we will return the value of the previous function fact 1 fact 3. Here the step for calling the function are finished. Need for need for the recursion. There must be the terminating with the recursion. There must be an condition if the recursion is routing reversion in the order execution. Every time a new recursive call is made, the duplicated value of the local variable of the recursive call are pushed. Disadvantage is consume more storage space. The computer may run out of the memory. There may not more efficient in terms of speed does not offer any concrete advantage if proper precautions are not taken. Recursion may not result in non-terminating removal of the recursion iteration in factorial. In fact, in number factorial n minus 1 return fact without using the recursion in factorial number in fact 1 p fact 1 return fact power of 1 in the game of the problem in case the disk is removed from the one pillar in the case a disk is removed from the one pillar, then with the use of the temporal another pillar to the another pillar with the use of the temporary pillar we can move only one disk from one pillar to the another at a time. The large disk cannot be placed on the smaller disk. Source temporary destination step 1 n is equal to 1 n is equal to 1 n is equal to 3 step 1 step 2 step 3 step 4 step 5 step 6 step 7 algorithm mm, move the 01 disk from the source to the temporary move the largest disk from the source to the destination procedure nst procedure nstd procedure n minus 1 std for n procedure 3 std then procedure std procedure std procedure 1 std procedure 1 sdt producer produce proceed transformation from the prefix to the postfix using the recursion in the prefix string is a single variable and its own postfix equivalent. Let the operator be the first operator of the postfix string. There the first operand and the string convert to the postfix. Concatenate post 1 post 2. mm, च्याप्टर 7 अब च्याप्टर 7 चाहिँ अर्को सेसनमा है एकछिन फ्रेस हुने